Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, we meet again this morning. Okay, Friday, Group B, CS 527, Indeterminate Structures. Okay, this is chapter number 1. So for today's session, I will divide the session into 2 parts. The first part is introduction about redundant. We will you are going to learn how we determine redundant and identify redundant for indeterminate structures, and we will also you will also learn about the primary system, the primary structure and redundant structure. And for session number 2, we will start with introduction to flexibility method, derivation of superposition method, derivation of compatibility equation using superposition method. Okay. Okay, most important, we need to understand that the final goal to learn flexibility method is to analyze structures, indeterminate structures. Whenever reaction is more than 3, we cannot determine using equilibrium equation only. So that is why we have to apply another method. Okay, so the idea is whenever we cannot determine the reaction because it is more than 3, we will solve the redundant. We will solve the redundant using compatibility equation. So the problem is the redundant. Redundant is reaction. Redundant is also reaction, but we have to solve the redundant first. We have to solve the redundant, and then only we can solve the remaining reaction, the 3 remaining reaction. So we will apply the principle of superposition. The principle of superposition states that actual structure is equal to primary structure plus redundant structure, and actually the principle of superposition is actually based on displacement occur at redundant position. So we will after this look at to the displacement occur. Okay, for all primary and redundant structure. Okay, take note that primary structure and redundant structure both are determinate structure. We actually divide from actual structure, which is indeterminate, to two system or two structures. Both are determinate. One is primary structure, one is redundant structure. Okay, then we will draw the diagram. We will sketch the diagram. We will sketch the primary structure. We will sketch the redundant structure. Both are determinate. So whenever it is determinate structure, of course, we can calculate reaction. We can write moment equation, and we can calculate displacement. Okay, so this displacement is the input of compatibility equation. So inside the compatibility equation is the redundant that we want to determine. So by solving the compatibility equation, we will get the redundant. Once after we determine redundant, then only we can solve remaining reaction. And the 3 remaining reaction can be determined using either equilibrium equation, or we can also solve the 3 remaining reaction using equilibrium equation. Okay, so in structural analysis, in indeterminate structures, for flexibility method, actually, we have 2 types of indeterminacy. So one is external indeterminacy, another one is internal indeterminacy. So external indeterminacy focus on the redundant, which is come from support reaction. Support reaction as redundant, we call it as external indeterminacy. Whenever member forces is redundant, we call it as internal indeterminacy. There are 2 types. External indeterminacy come from support reaction. Internal indeterminacy come from member forces, basically in the truss system. And redundant also can be both external and internal for case for indeterminate structure with 2 redundant. So now we focus on 1 redundant first. Okay, basic understanding about how to determine determinate and indeterminate structure is very important. Just use the basic calculation of calculating DOI for beam and frame, because we only considering bending effect, is the difference between unknown reaction and 3 equilibrium equation. It is direct way to determine the indeterminacy, the degree of indeterminacy. But for truss, we have to consider the member whenever we calculate DOI. So for truss, we will use M plus R minus 2J. So why DOI is very important? Because it helps engineers understand the level of complexity in solving for forces in a structure, where a higher DOI means more complex analysis method. So we will use flexibility method to solve the indeterminate structure for first chapter, and stiffness method is the second chapter. Anyway, for success in flexibility method, the basic understanding of how we can determine reaction, internal forces, as well as displacement, using whatever you have learned in solid mechanics, especially in beam topic. And then in determinate structure course, especially in frame topic, frame truss, as well as deflection topic, is very, very important in order for you to success in this flexibility method. Okay, in flexibility method, we will cover 4 types of structure. Start with beam analysis, beam, frames, and truss. And type number 4 is composite structure. Okay, so for this week session, I want you to understand about redundant, because it is very important. Even so, once you understand what is redundant, how to choose redundant, the right redundant, how many possible redundant in the system, what is the primary structure, what is redundant structure, how to draw the right primary structure, how to draw the right redundant structure, that is very, very important. Because once you understand all this, we can apply the same to different type of structure. Of course, the derivation of flexibility method to get you to understand this method, we will be focused on beam analysis, but please try to understand it very well, because once you understand it, we can apply the same principle, the same concept to other type of structure. Okay, basically this is the procedure. The procedure is we have to identify redundant. Redundant will be removed from the system. Okay, so we have to identify redundant. How to identify redundant? From the formula, DOI formula. Okay, so for example, 4 minus 3 is equal to 1. So 1 is the redundant, 1 is the problem. Because whenever we have 4 unknown reaction, we cannot determine we cannot determine all 4 directly using equilibrium equation, and we cannot determine we cannot determine these 3 unknown reaction if we don't calculate redundant. We have to calculate redundant first. So and in order to calculate redundant, what we need to do is we have to identify redundant. We have to identify the right redundant, because we have to determine the redundant value. So how to identify redundant? Okay, actually it will be depend on understanding of the support concept. The support concept, we have fixed support, we have pin support, we have roller support. For example, if we want to remove one reaction in fixed support, so fixed support, whenever we want to change from fixed to pin, we have to remove moment. So from fixed support, if we have fixed support, we want to remove 1 from fixed, so it will become pin. One redundant, if we want to remove from fixed, we have to change the fixed support to pin support. So to change from fixed to pin means that we have to remove moment, so that after we remove moment, it become pin. Okay, so kalau pin, if pin support, we want to remove 1, we have to remove the horizontal reaction, so that it become roller. So if it is roller support, we want to remove 1 from roller support, it look like we remove the roller. Okay, so we have to understand that redundant redundant has the characteristic. Okay, we have to remove the right redundant. We cannot simply just remove one. We have to understand the concept of support so that we choose the right reaction to remove as the redundant. Okay, so the basic idea is whenever we remove redundant, the structure after removing redundant can become kalau beam cantilever beam, become cantilever beam or simply supported beam. There are two types of determinate beam. Remember, there are two types of indeterminate beam. There are two types of determinate beam. Determinate beam, it is cantilever beam or simply supported beam. So we can have cantilever beam to analyze. We can also choose simply supported beam to continue the analysis. Okay, so if we choose to have cantilever beam, so we have to remove moment. We have to remove moment, and if we want to analyze simply if we want to remove moment, we will have simply supported beam. If we want to remove roller, we have to remove the BY. So later on I will show in the diagram. Okay, so step number one, we have to identify redundant. We have to choose redundant. We have to identify redundant and then choose redundant. And the structure after removing redundant is determinate structure, and it is called as primary structure. So we remove redundant. Okay, so we after we remove redundant, so we have to refer to the displacement at the redundant position. Okay, then we have to apply compatibility equation. We have to apply compatibility equation because the redundant will be determined from compatibility equation. By solving compatibility equation, we get the redundant. By solving compatibility equation, we get the redundant, and actually compatibility equation is based on superimposed effect. So we will derive the compatibility equation, okay, in the next 1 hour session. Okay, the key characteristic, okay, it is just the notes which actually similar with the previous slide. Okay. Okay, this is the key step. We have to identify and remove redundant. One redundant, we have to remove one DOI, we have to remove one redundant. Two DOI, we have to remove two redundant. Okay, so after removing redundant from the system, we will have determinate system. Once after we remove redundant, we will have determinate system. And this determinate system is called as primary structure. Then we apply the principle of superposition, and we derive the compatibility equation. So we after we have the compatibility equation and we understand that the compatibility equation is come from displacement, so we have to calculate displacement. And we will use all the knowledge that you have learned previously in order to calculate displacement. Displacement come from formula. So inside the formula is moment equation, and moment equation will be determined after we determine reaction. So that's the process. So, and after that, we can solve for the redundant. Okay, that's the idea. Okay, so in the OneNote, I have actually put the textbook, and then under the flexibility method, the module is here, so you can read. Also, this is also the module that you have bought, right? Okay, so actually this is the same with what I have explained previously. Okay, so the idea is like this. So move to this. Okay, so what I'm trying to tell you just now is when we have determinate structure, we have cantilever beam, we have simply supported beam. This is determinate structure for beam. So let's say loading like this. Okay, loading like this is determinate beam. This is the first one is cantilever beam. The second one is simply supported beam. Okay, these two types is determinate beam that you have learned in solid mechanic. So in the first diagram, it is cantilever beam because there are three unknown reaction at fixed support, and the second one is simply supported beam, one fixed, one roller. So there are three unknown reactions. So that's why DOI for these two is 0, DOI for these two is 0. Okay, these two type of beam is are the simply the determinate beam. One is cantilever beam, one is simply supported beam. Okay, now in indeterminate structure we have this. In indeterminate structure we have more support. Okay, let's say we have the same beam, but I add another support at B. So let's say this is A, this is B. Okay, 10 kilonewton per meter, this is 10 meter. Now, looking at the support, A is fixed. There are three unknown reaction, and B, there are BY, BY is roller support, one unknown reaction at B. So total, there are DOI is 4 minus 3 is equal to 1. So this value 1 is actually represent number of redundant in the system. One redundant, like this. Okay, so by applying principle of superposition, in principle of superposition, okay, the general equation states that actual structure is equal to primary structure plus redundant structure. Under principle of superposition, actual structure is indeterminate structure. This is indeterminate structure. And indeterminate structure, we divide into two systems. One is primary structure, one is redundant structure. And take note that both primary structure and redundant structure both are determinate. So this is determinate structure. This is also determinate structure. Okay, both are determinate structure. Okay, so now we actually will draw the primary structure and redundant structure. Okay, remember that the primary structure and redundant structure, where both are determinate structure, can be A, can be B. Okay, A is not this. Okay, can be A, can be B. What is A? A is cantilever beam. What is B? B is simply supported beam. Okay, so both diagram describe in the principle of superposition, the primary structure, the redundant structure, both of these can be cantilever beam, can be supported beam, depending on the redundant that we will choose. Okay, for example, if we want the system to be analyzed is cantilever beam, we will remove BY. To have cantilever beam, from this one, to have cantilever beam, the reaction that we remove is BY. So BY is the redundant. Okay, if we want to analyze the determinate beam using simply supported beam, if we want because we can only choose one. We do not have to do both. We just need to choose one system to analyze, to be analyzed. Okay, if we want to analyze simply supported beam, the redundant is moment. The redundant is moment, because if we want to have cantilever beam, we have to remove this roller. If we want to analyze cantilever beam, we have to remove roller. We have to remove BY, means we remove roller. If we want to analyze it as simply supported beam, we have to remove moment. We have to remove moment if we want to analyze the simply supported beam. Okay, so we have to remove. So the one that we remove is the redundant. The one that we remove is the redundant. Okay, so for analyzing this beam, as using cantilever beam, so redundant can be BY or MA, but we can only choose one as redundant. Okay, one as redundant. So let's say we choose to have cantilever beam. Okay, if we choose to have cantilever beam, let's say we choose BY as the redundant, BY as the redundant. So what happened is we will have the cantilever beam for both of these, primary beam and also redundant beam, if BY is the redundant. Okay, BY is the redundant. So what we need to focus here is, okay, actual structure is the original one, the given question. Okay, removing redundant means we will have two determinate system. One is called as primary structure, another one is called as redundant structure. So in primary structure, the only one that we remove from the beam is the support. So loading, we do not remove loading. Loading is there. Let's say here is UDL. Okay, so it is like this. Kilonewton per meter. Okay, this is primary structure because the one that we remove is BY. Okay, so we have to remain all loading, all external loading remain. We only remove BY. We only remove BY. So where is BY now? BY, okay, we put under different diagram. It is called as redundant diagram. Redundant structure. So here is BY. So that when we plus back this primary structure plus redundant structure, we get back original. We get back actual structure. In actual structure, we have external loading and BY and roller. And roller here, right? So roller here means BY. Okay, so we divide into two systems. We call it as principle of superposition. Okay, we remove BY, we identify redundant, we choose redundant to be removed. So the structure after removing redundant is primary structure. The primary structure is determinate structure. Determinate structure. This type is cantilever beam, so that we can analyze reaction, we can analyze the moment equation, we can analyze for the displacement. Okay, and where is the BY? So BY we will put under the same type of beam. If primary structure is cantilever beam, the redundant structure also cantilever beam, but this time this cantilever beam is only subjected to BY. So this is the basic idea about the principle of superposition. the principle of superposition. If we want to have simply supported beam, for example, if we want to have simply supported beam, so we have here simply supported beam. Reaction is reaction for simply supported beam come from pin, come from roller. Okay, loading is there. We do not have to remove loading. Okay, the only one that we remove is MA. So where to put the MA? We will have to have another one, another simply supported beam. But this simply supported beam, we apply the moment. We apply the moment here. This is the moment that we remove. The moment that we remove. This is the idea, the principle of superposition like this. Okay, we can have the first one is cantilever beam. There will be two systems to be analyzed. One is primary structure, another one is redundant structure. Okay, both are cantilever beam. If we want to have a simply supported beam to be analyzed, so we remove MA as the redundant. So we have the cantilever beam without MA, of course. Loading is there. We do not remove loading. Okay, it is just simply supported beam with external loading plus another same type, same simply supported beam, but for this one we have to apply back the moment at A that we removed previously. So this is the basic idea of principle of superposition. Principle of superposition. The basic idea. Okay. So not only this, but to analyze for BY, to analyze for redundant, we actually need to understand that BY, this BY, okay, this BY, we will change to 1 times BY. 1 times BY. Same goes to moment at A. Moment at A, we will assume that it is 1 times MA. Okay, BY is 1 times BY, MA is 1 times MA. Okay, for the redundant. Because here, by looking at this diagram, for the primary structure, we can analyze for reaction because external loading is the value given, right? The value. But by looking at the redundant structure, for example, this one, can we analyze this? Can we analyze this? We cannot analyze this because BY is the unknown. BY is unknown, so we cannot analyze the reaction, the internal forces, and the displacement. So what should we do? So we will change this BY to 1 times BY. 1 times BY. Okay, but normally BY we just put outside because not only BY, everything in the system times with BY. The reaction must time with BY, the internal forces must time with BY, the displacement must times with BY. So in the analysis, later on, we will analyze this one. Okay. The redundant diagram, the redundant structure is a determinate structure. Determinate structure subjected to a unique value of BY. So yang ni kita kata a unique value of BY. A unique value of BY. A unique value of BY. So semua ni ada dalam modul, ada explanation yang saya tulis. Okay. But this one, because I put a point load here, right? Point load here. So I have to have A, B, and C. So here is C. So the redundant here is CY. CY, same. Because redundant will be depending on the position. If it is B, BY. If it is C, CY, DY. Okay. So this one is CY. Okay, this is the primary structure. Okay, again, this is 1 times Cy. 1 times Cy. Just like previously, I said 1 times By. 1 times By. So all the characteristic I have list all here. So please read. Okay, please read. Okay, so I want every one of you to really understand about this concept, because this is very, very, very important. Very, very important, because after this we will deal with the indeterminate structures with more than one members. This is just A, B, right? So we will have A, B, C. We will have uh, loading, more than one type of loading. It can be combination of UDL, triangular load, point load, moment, and so on. But most important is we need to understand, you need to understand what is redundant, what is primary system, what is redundant system. Okay, let's say we have this. Okay, wait. Okay, let's say we have this. This is fixed. This is roller. We have loading like this. We have point load here. So many. Okay, doesn't matter. Okay, I want to have this first. Okay, this is 10. This is 10 kilonewton per meter. Okay, so this is simply supported beam. This is indeterminate beam because one fixed, one roller. 4. DOI is 4 minus 3. This is 1. So there is one redundant and we have to choose the redundant. We have to choose the redundant. So let's say we want to choose. So this one, A, B, C, and D. Because why? We will later cut the section. So to write the moment equation, we will have 1, 2, 3 cutting section. So we have A, B, C, and D. Okay, so in this case, dy is the redundant if we want to analyze cantilever beam. So this time, the redundant is dy. So if dy is the redundant, means we remove redundant. We remove redundant. And from the principle of superposition, the principle of superposition, okay, we have actual beam, which is equal to primary beam plus redundant beam. Okay, from the principle of superposition, we will have primary beam plus redundant beam. And the redundant now is dy. Okay, so we have the primary beam. The primary beam is, okay, cantilever beam. Cantilever beam for both primary beam and redundant beam. Loading remain in the primary beam because the only one that we remove is the redundant. Okay. And then for redundant beam, we have to apply a unit value of dy. So this is the diagram. Okay, one is primary beam, one is redundant beam. This is how the diagram looks like. Okay, so the first one is now cantilever beam. Cantilever beam, it is primary beam. Primary beam, you have here A, B, C, and D. A, B, C, and D. And we have to remain the label A, B, C, and D here as well because we have to have the same cutting section for both diagram. Okay, so for the redundant beam, we will have a system, a determinate system, a cantilever beam subjected to a unit value of dy. So yang ni we say like this. This mean a cantilever beam subjected to a unit value of dy. And please see the characteristic of this beam. Okay, the first one, the primary beam, is just like real system. Real system, the one that you have learned under unit load method. The characteristic, it has same characteristic. What is the characteristic of real system? It is determinate structure, real loads, or external loads. External load. Real system. Okay, we try to compare with the one the method that you have learned under 424 or 429. 429. Okay, real system, the characteristic is it is determinate structure, and this determinate structure is subjected to real load or external load. Okay, and another one is the virtual structure, virtual system. Virtual system is also determinate system, same type of real system, same one. Same, both cantilever beam, okay? And in the virtual system, it is a determinate structure subjected to a unit value. A unit value. A unit value. Okay, but don't have dy, right? Now we have a unit value of redundant. That's the difference between redundant structure and virtual structure. Okay, for redundant beam, it is a system, a structure, a beam, a frame, a truss subjected to a unit value of redundant. And by comparison, the virtual system, virtual beam, virtual frame, virtual structure is a determinate system subjected to a unit value. Okay, means that for the analysis, we will analyze two system. One is analyzing of primary beam, and another one is analyzing of redundant beam. So we will analyze two systems for one redundant. Two redundant, we will have three systems. Okay, one redundant. We focus on one redundant, so that this is the comparison for you to understand more about what is superposition method or flexibility method. Okay, so that is why I have said to you previously as well, in the previous class as well, to solve for the redundant, to get the goal, the objective, we actually analyze all determinate structures. The flexibility method is only the concept. The flexibility method is only the concept, but for the analysis, we will analyze all reaction, internal forces, as well as displacement. Okay, so this is an example where we have A, B, C, D, an indeterminate beam. The member, there are three members, A, B, B, C, and C, D, with one uniformly distributed load along BC. It is like this. So what if, for example, if we have this one? Okay, now I want to put roller here. This is roller. This is fixed support. Okay, now this is point load, 100 kilonewton, for example. Okay, we have one UDL. Okay, like this. So for this beam, this is indeterminate beam. Looking at the support, there are 4 unknown reaction, 4 minus 3. So this is one redundant. So we can choose either A, B, C, and D. So if we want to have cantilever beam as the primary system, primary system and redundant system, of course. Okay, we have to remove the roller at D. But if we want to have or to analyze simply supported beam, we have to remove moment at D. Let's say we remove moment at D. So to remove moment at D means the fix at D will change to pin because we will again apply the principle of superposition. We apply principle of superposition, okay, and this is come from actual beam equal to primary beam plus redundant beam. Redundant beam. That's the idea, redundant beam. Okay. Okay, the primary beam and redundant beam, both are simply supported beam. If we choose MD as redundant, means that what we have now is, okay, two simply supported beam. Here is roller, here is pin. Same to both diagram. The difference is only due to loading. The first one, the primary beam, we have determinate or simply supported beam subjected to all external loading. So here is A, B, C, and D. And we also have the same A, B, C, and D. Okay, but for redundant beam, we have to apply. Moment at D, and it is a unit value of MD. Okay, for the redundant beam, it is a unit value of MD. Okay, this fulfill the principle of superposition. The principle of superposition, because later on when we want to write the moment equation, we will have 1 cutting section, 2 cutting section, 3 cutting section. And the cutting section must standard. So for redundant also must follow the 3 cutting section. Okay, so these are the 2 determinate system, determinate beam to be analyzed. One is called as primary beam, another one is called as redundant beam. Primary beam, redundant beam. Okay, this is primary beam, this is redundant beam. Primary beam, redundant beam. Okay, so this is a unit value subjected to a unit value of MD. A unit value of MD. Okay, let's say we have frame. Let's say we have frame. This frame. Okay, so one is fixed, one is roller. We have UDL. The label is A, B, C. Okay, so DOI, looking at the support, there are 4 unknown reactions and only 3 can be determined using equilibrium equation. So 1 is the redundant. Okay, so when remember to have stable structure, stable and determinate frame, we can have the frame subjected to one fixed support or 1 pin 1 roller. 1 pin 1 roller. So we can we still have 2 possibility. Okay, so let's say we want to remove moment at A. Moment at A, so fixed become pin. Fixed become pin. So let's say the redundant is moment at A. Moment at A means we remove moment at A. Moment at A means fixed. Fixed become pin. Okay, moment at A means fixed become pin. Okay, so if we have this, again, we have to apply principle of superposition principle of superposition, it states that the actual frame equal to primary frame plus redundant frame. Okay, the principle of superposition. So we will have two systems, two determinate frame to be analyzed. We have two determinate frame to be analyzed. One is called as primary frame and another one is called as redundant frame. Okay, redundant frame. Remember, the moment at A is the redundant. So means that when we remove moment, fixed become pin. Okay, so we have primary frame and redundant frame, same frame. Two frame now. One is primary, one is redundant. Okay, so now fixed become pin and roller remain because this is stable and determinate frame. Okay, for primary frame, loading is remain. The only one that we remove is only moment at A. So here A, B, C. A, B, C. So same label A, B, C, same system, same label, same support. Okay, the only difference between these two diagrams is the first one, the primary frame is a determinate frame subjected to external loading. All external loading remain. But for redundant frame now it is, because this is plus, yeah, okay. So this is a redundant frame subjected to a unit moment. A unit moment. A unit value of MA. A unit moment is a unit value of MA. A unit value of MA. A unit value of MA. So this is the frame example by applying the principle of superposition. Okay, so later on we have to analyze two cutting section A, B, and B, C. Okay, this is the frame. So if we have frame like this, for example. So again, this is fixed, this is roller. Okay, now we have UDL. We have point load here, for example. This is 200. This is 25. We have moment, 300, for example, kilonewton meter. Okay, so now we have this is actual frame A, B, C, and D. Okay, A, B, C, and D. Okay, now looking at the support, looking at the reaction, there are 4 unknown reaction. For DOI, this is 4 unknown reaction. Only 3 can be solved using equilibrium equation. So the difference is 1. 1 is the redundant. So redundant here can be 1 from one from A, or just remove the roller. Either one can be the redundant. Okay, so if we want to have MA, so let's choose MA again for this frame. So we have MA as the redundant. MA as redundant means we change from fixed to pin. A, support A, fixed become pin. Fixed become pin. Okay, so we apply principle of superposition. It is actual frame equal to primary frame plus redundant frame. Okay? Okay, so we have two determinate frame. two determinate frame to be analyzed. Okay, and remember there are two with the same type. One is primary, one is redundant. Same type, same support. Okay, same support. Okay, the first one, primary frame, remain all external loading. External loading, UDL. Sorry. Like this. Roller. Okay, so UDL remain. Moment remain. Point load remain. Remain all external loading in the primary frame, because the only one that we remove from there, okay, is the moment. Okay, so now we have another one, the redundant frame. Same type, same support, but here we apply a unit value of MA. A unit value of MA. MA ni macam outside the system. MA ni dia duduk dekat luar ya. Outside the system. MA. Because not only moment tu yang 1 times MA, but everything inside the system times MA. The reaction due to a unit value. The reaction times MA. The displacement times MA. Because everything. Okay. We are the system. The whole system times with MA. Okay, so we have this. So the first one is primary frame. The second one is the redundant frame. Okay. So I hope you understand about the redundant, how to choose redundant, the principle of superposition, okay, the characteristic of primary frame and the redundant frame. Not only frame, but it can be applied to all types, all type of structure, including truss as well. We apply the same principle. Okay, the same understanding. Same goes to truss. Okay, same goes to truss. Okay, do you understand? Do you have question? Before we move to the second part of this 2-hour session, I will show to you how we will derive the compatibility equation. Do you have any question before we move to the next part?
No, madam.
Is it clear?
Yes, madam.
Clear, Doctor.
Okay. So can we move to the next part?
Madam,
Yeah.
can we take a 5 minutes rest, madam?
Can. Okay, we meet soon at 9:05. Okay.
Okay.
Okay, Assalamualaikum. We continue. Okay, we are now moving to principle of superposition, the derivation. Okay, it is based on the principle of superposition. Okay, so this diagram shows the idea, the concept of principle of superposition. So the diagram come from the general equation, start from actual beam equal to primary beam and redundant beam. So normally the redundant will be okay, this is redundant beam, but normally we write as this redundant by applied, because by is subjected to as an applied load. By is subjected as an applied load, so the redundant beam can be written, the redundant beam name can be written as redundant by applied. So if CY is redundant CY applied. If MA is redundant MA applied. Okay, just like this. So this is the basic of principle of superposition. So always remember the principle of superposition, the general equation, actual beam plus equal to primary beam plus redundant beam. So always remember this principle of superposition, the general equation. Because after this, we will focus the analysis will be focused on analysis of primary beam, primary structure, and redundant structure. Okay. So so this is the one that is written in the module. So I want you to read module chapter 1 about the definition of redundant, the principle of superposition, the procedure. Okay, because normally in class I will talk and talk and please read before and after for more understanding, yeah, to understand more. Okay, so this is the idea, the concept. I believe you have understand from the previous that I have explained. Okay, so we continue here because we want to learn how to get the how to derive the principle of the compatibility equation. Okay, for example, we stick to the example with one member only, a member AB subjected to ULM, uniformly UDL, uniformly distributed load along the member. So we choose this. Okay, one fixed, one roller. One fixed, one roller. So this is A and B. Let's say this is 10 kilonewton per meter. This is 10 meter long. Okay, this is indeterminate structure. Okay, indeterminate structure, because when we check for DOI, it is 4 minus 3 is equivalent to 1. There is one redundant. Okay, the beam can be called as indeterminate beam. This is indeterminate beam to the first degree of indeterminacy. Okay, you can have this on your OneNote as well, yeah. Okay, so this is one redundant. So this beam is indeterminate beam to the first degree of indeterminacy. Okay, so we have to choose redundant. We have to choose redundant because we want to remove redundant. Okay, we want to derive the compatibility equation by analyzing cantilever beam. So in this case, we want to choose BY is the redundant. BY is the redundant. We will choose BY. So the position now is B. B is the position, the displacement position. Okay, position dia. Okay, the redundant position redundant position at B. At B. So after this, we will focus on the displacement at B. Displacement at B. Okay, now we apply the principle of superposition. Apply the principle of superposition. We apply principle of superposition. Apply principle of superposition. It states that actual beam is equal to primary beam plus redundant beam. Okay, this is the principle of superposition. Okay, remember the compatibility equation is come from displacement at B. Displacement at B. We have to look at to the displacement occur at all actual beam, primary beam, and redundant beam. Okay, so we have to draw the diagram for all this system. Start with the actual beam. Start with actual beam. So we now draw actual beam. So this is actual beam. Okay, A and B. This is actual beam. Actual beam equals to cantilever. Two cantilever. One is for the primary system. One is for redundant system. Two cantilever. Okay, the first one is the cantilever beam subjected to all external loading. And the second one is redundant beam. Okay, for both determinate beam, we have primary beam, we have redundant beam. Okay, this one is a unit value of By. Okay, so we label as actual beam. This is actual beam. This is primary beam. And this is redundant beam. This redundant beam, okay, can be written as redundant By applied. Redundant By applied. Because By that we apply now, we do not put the roller, but we assume that this is an applied load. That the By is an applied By subjected into the system. So that's why we put as By applied, redundant By applied. It is redundant beam. It is redundant beam, but we put the name of the redundant we chose here. Redundant By applied. So redundant By applied. Redundant By applied. So this is times By. So that we do not lose. If it is moment at A, redundant MA applied times MA. You get what I mean? If redundant CY applied times CY. Okay, so it is redundant By applied times By. Okay, so we have three systems: actual beam, primary beam, redundant beam. Okay, so we need to focus to the displacement at B. Displacement at B, because compatibility equation come from displacement, focus at redundant position. We will write the displacement equation actually. Displacement at redundant position. B is the redundant. B is the redundant position. So draw the displacement for each of these. So looking at the first one, actual beam subjected to this 10 kilonewton per meter UDL. How the displacement or deflected shape of this beam? Okay, fixed roller. Fixed, sini fixed, here is fixed, this is roller. How the deflection look like? Okay, this is fixed, so like this. Okay, lebih kurang lah. Okay, because kat sini fixed support, no displacement, no rotation, no vertical displacement, no horizontal displacement. So when we draw the deflected shape, dia tak boleh start from this, right? Okay, you learn about the effective length under buckling system, so we apply that one here. Okay, so this is deflection at the deflected shape for actual beam. We focus at B. So at B, in actual beam, at beam, delta at B, delta at B equals to, roller means deflection is 0. Roller means deflection is 0. Okay, roller means deflection is 0. So at B, delta B equals to 0. That is occur in the actual beam, in actual beam. Okay, next, primary beam. So whenever the cantilever beam subjected to UDL 10 kilonewton per meter, what happened? There is no roller anymore. It is cantilever beam. What happened? Deflect like this. Because there's no more roller here, it is just cantilever beam. It deflect like cantilever beam. Okay, now we have to mark displacement or deflection at B. Deflection at B. We have to mark that one. Okay, mark the deflection at B here. Okay, the deflection at B occur due to the uniformly distributed load. Okay, we will have delta as well, but now it has value. It is labeled as delta. Okay, now we will put two notation. So all this I described, I wrote in the module. Okay, delta at position B for primary beam. There is two notation used here. Okay, because of course we cannot use the same symbol, right? Okay, so all this have meaning. Okay, cara baca dia is deflection at position B for primary beam. Deflection at position B for, not is the symbol for primary beam. Not is the symbol for primary beam. So delta B naught means deflection at position B for primary beam. Not is always the symbol for primary structure. Okay, so delta B naught, we should already understand. Delta B naught belong to primary system. Even though it is delta B naught, delta A naught, delta C naught, delta D naught. So naught is the label for the primary system. Okay, even it is theta, rotation. Theta A naught, theta B naught, theta C naught, naught is the symbol for primary system. Okay, so delta B naught means deflection at position B for the system, the primary system. So that is how we read this symbol. Delta at position B for primary beam. So that is delta B naught. Okay, delta B naught. It is deflection. and we are going to determine this value. It is deflection and we are going to determine this value. Okay. So next one, redundant BY applied. Redundant BY applied. Okay, we have the same type, a cantilever beam, but this time it is subjected to a unit value of BY. It is subjected to a unit value. A unit value. So due to this diagram, this redundant diagram, it will deflect upward because a unit value shows here, right? Okay, so deflect upward due to a unit value of BY. Again, we mark the delta. Okay, now like this, okay, and we label as, okay, look at the diagram carefully. This is a cantilever beam due to a unit value of BY. Okay, this is a cantilever beam subjected to a unit value of BY. So due to a unit value of BY, delta is F. Okay, the redundant system, in the redundant system, the deflection due to a unit value will be labeled as F. F. Okay, F, yeah, everybody? It is F. For the redundant system. Redundant system, the deflection is labeled as F. The rotation is labeled as F. F. Okay, what is F? Deflection. Because the idea is it is delta BB. Because this one times with BY, so now change to F. So we apply FBB into the system. FBB. FBB. And FBB times BY equals to delta BB. Delta BB. Okay, so this is how the redundant diagram look like. It is a system. This is a cantilever beam subjected to a unit value of BY. The deflection occur due to a unit value of BY is labeled as F. We cannot label as delta. Delta is F times FBB times BY. So you can forget about this. You can forget about this, doesn't matter. But this one, apply this one. FBB times BY. FCC times CY. FDD times DY. FAA times MA. F times with the redundant. Okay. So again, all these have meaning, right? All these have meaning. F, what is F? F is deflection due to a unit value. F is deflection due to a unit value. F is deflection due to a unit value of BY at position B for redundant BY applied. For redundant BY applied. For redundant beam. For redundant beam. F is deflection at position B. F is deflection at position B for redundant beam. So in the redundant beam, we use the symbol of FBB to show the displacement. To show the displacement. Okay. So we have this. Actual beam, primary beam, redundant beam, redundant BY applied. Okay, now we will relate all this using the principle of superposition. Using the principle of superposition, we will write the equation. The equation of displacement. The equation of displacement from the principle of superposition. Remember, the principle of superposition states that actual beam equals to primary beam plus redundant beam. Okay, so now at B, Actual beam is delta B. Actual beam is delta B. In primary beam, delta B naught is deflection at position B. And for redundant beam, it is actually delta BB. Originally, BY is there, right? But after we change to 1 times BY, we also change this to FBB times BY. Okay, so delta B is equal to delta B naught plus FBB times BY. Okay, so original is this. Because this is due to BY, but this is due to a unit value of BY. Okay, so which one can be used to solve for the redundant? Of course, the second one. That is why we have to change to a unit value of BY. Because in the second equation, we have here BY, the redundant, and we want to solve this BY. Okay, so we use this one as the compatibility equation. So it is come from actual beam equals to primary beam plus redundant beam. All displacement we get from this diagram. Okay, we get from this diagram. So to complete the compatibility equation, compatibility equation equation. Okay, since delta B is equivalent to 0, right? Delta B is equivalent to 0 here. Delta B is equivalent to 0. It means that we can actually change position, because normally we write equals to 0, right? We do not write 0 equals to something. It is something equals to 0, right? So we change position. So the compatibility equation for this beam, the redundant is BY, is written as delta B naught plus FBB times BY. And this is equal to actual. Actual is 0. So this is the compatibility equation. Okay? Compatibility equation like this. Delta B naught plus FBB times BY equals to 0. So what is delta B naught? What is FBB? Both are displacement. Okay, the unknown, the one that we want to calculate here is BY. We want to solve this BY by solving this compatibility equation. It means that we have to determine displacement, delta B naught and FBB. Delta B naught displacement, FBB also displacement. Delta B naught displacement, FBB also displacement. Again, to calculate these two displacement, we will adapt and adopt. Okay, adapt and adopt the formula that you have learned previously under deflection topic, principle of virtual work or unit load method, where we will integrate moment equation to get the displacement. Okay, do you remember this formula? Do you remember this formula? 1 dot delta 1 over EI. One is from real system, one is from virtual system, dx. So this is the idea. Not same because that is why I said adopt. Kita ubah balik sesuaikan dengan konteks flexibility method. Okay, flexibility method. In flexibility method, we have delta B naught and FBB. The idea is we will integrate moment equation, two moment equations, same as this. This is come from two moment equation as well. This come from real system, real structure, and virtual structure, virtual system. But in flexibility method, we have primary system and redundant system. Okay. So now inside this, we have two displacement, delta B naught and FBB. The formula is delta B naught, we integrate 1 over EI from 0 to L. There are two moment equation. There are two moment equation. Two moment equation, dx. Okay. Two moment equation. We have here notation. We use B and naught. B and naught. So put here MB M naught. MB M naught. Just follow the notation that we use in the displacement label. It is delta B naught. Delta B naught. Delta B naught. We use here one is MB, one is M naught. One is MB, one is M naught. Okay, MB, M naught. So that you don't have to remember. Okay, just follow the flow. Follow the flow only. Delta B naught, we have to understand, I believe we understand that this is displacement, and this displacement, to get the value, we have to integrate two moment equation, means that it comes from two system. So the system is what? The system. Okay, based on the label B and naught, remember naught is always the label for the primary system. So B is actually referring to the redundant system. Redundant system. So we have MB and M naught dx. This is for the first one, delta B naught. Another one is FBB. Another one is FBB. So FBB is also displacement. This is due to a unit value of redundant. Again, same formula from 0 to L. Two moment equation, but this time it is BB. BB, 2 times of B. BB, 2 times of B means that we have MB times MB. MB times MB is MB squared. MB squared dx. Okay, MB squared dx. So this is the two formulas to calculate displacement here. Okay, so inside this formula, there are two symbols that we can find here, two moment equation. So the symbol used here, we have M naught and we have MB. And remember, naught is always for the primary system. So we know that this is come from primary beam. And MB refers to BY as the redundant. Symbol B we use here is referring to the redundant BY applied. So this is redundant, come from redundant beam. It is redundant BY applied. Okay, so moment equation. So actually, the most important thing here is, okay, we understand that we have to solve the redundant. We have to solve the redundant. This is the redundant. Because this is our aim. This is our aim. Of course, when we have to analyze the indeterminate structures, okay, we have 4 unknown reaction, right? This 4 unknown reaction is actually 3 and 1. Because after we get this one, then only we can get another 3. Okay, so the main problem here is the redundant. 1 is the redundant. This is redundant. Okay, that's why I said previously, I'm not sure in which class. Okay, so we have to be to understand. You don't need to remember. Please understand. So to understand, we have to set our goal. We have to set the goal first. That is why every lesson every subject, every course, every programs, and also we ourselves must have objective. Objective is outcome. Objective is goal. Objective is destination. So we have to know that when we learn flexibility method, why? Why flexibility method? So what is flexibility method? Okay, we use flexibility method for indeterminate structures whenever three equilibrium equation is not enough to solve for the reaction. Then we have to we have more than three, right? More than three. So we have redundant in the system. And the problem here is the redundant. The problem here is redundant. So every one of you should understand that the goal, the objective, the outcome for flexibility method is to determine the redundant, because only after we get the redundant, then we can solve for the remaining reaction. So we want to analyze all reaction, because in structure analysis, the reaction is the reaction is very important. Start with reaction, then only reaction, and then internal forces, and then this deflection. And deflection is the behavior of the structure. From deflection, then we move to design process. Okay, so the goal, the objective, the outcome is to determine redundant. The problem is redundant, so we have to solve the redundant. So how to solve the redundant? We can get redundant by solving compatibility equation. So this redundant can be determined by solving compatibility equation. The redundant will be determined by solving compatibility equation. Solving compatibility equation gives us the redundant. What is compatibility equation? If By is the redundant, compatibility equation is delta B naught plus FBB. Because By is redundant, we put By here. So this is 0. Okay, so this is the compatibility equation if By is the redundant. So we have to understand that inside the compatibility equation, there are two displacement. There are two displacement. Inside the compatibility equation, we have this and this as displacement. Delta B naught and FBB. Look at this, look at to the symbol delta B naught. We must understand that because of the naught symbol, it is the primary system. The primary system. And FBB, because of the label F we use here, this is the redundant system. FBB times By. So we have two systems. We understand that there are two systems. One is primary system and another one is the redundant system. Okay, so we understand now the formula to solve this delta B naught and FBB is actually by integrating moment equation from two systems. The first system is primary system, primary beam. The second system is the redundant beam, redundant By applied. And this is displacement, right? This is displacement, right? So displacement we get from internal forces. Internal forces we get from reaction. Okay, the flow. So this actually flexibility method, only this. Only this. This is the flexibility method. Only after we can calculate displacement, then only we can get the reaction in indeterminate beam. So we have to determine displacement. So this displacement. So we want to have the displacement, we have to start with reaction. Okay, the flow is start with reaction. The flow. Okay, the reaction. After reaction, we write moment equation. And moment equation is to be used in the displacement formula. Displacement. This is the flow of structural analysis, reaction, moment equation and displacement. So displacement ni nak masuk sini. So we have to go through the process of calculating reaction, writing moment equation and determine displacement. Displacement, there are two types, displacement in primary structure, displacement in redundant structure. Okay, then only we can solve the BY, the redundant. Okay, so in summary, we have to analyze for one redundant system, okay, we will have two systems. We have two systems. System number one is the primary system. System is refers to the structure, yeah. System, structure, beam, frame, truss, same. Okay, the primary system, and number two is redundant system. Okay, so there are two system, primary system and redundant system. So apa nak buat dengan this system? Number one, kira reaction. Number two, we will write moment equation. Number three, we calculate displacement. Displacement for both primary system, redundant system. Okay, the label for displacement will for moment equation, the label for moment equation is M0 and M1, MB. Okay, MB for this one, whenever we use label B, so it is MB, MC, MD, depending on the label that we use in the redundant. So of course, beside label like this, we will have one standard label for representing the redundant system. Okay, because kalau yang ni BY is redundant, we use MB. CY is redundant, we use MC. DY is redundant, we use MD. EY is redundant, we use ME. But to be applied to all types of problem, of course, there will be one standard form. The standard form is actually in numbering. So actually we can use, okay, like this. For example, if we have one beam like this. One beam, point load like this, UDL like this, for example. Okay, so now we have A, B, C, D. Okay, DOI is 4 minus 3, 1. One redundant in the system means R1. So R1 in this case can be moment at A, can be roller, vertical reaction at D. Okay, it can be MA or it can be DY. Okay, so instead of using label D and label A, moment at A, we use label A. DY, we use label D. Instead of using this label, we can have one standard label, right? One standard label will be using 1 for one redundant. So the compatibility equation will be written as delta. Okay, okay, just now B not right. No, now B we change to 1. So it become 1 not. Plus BB we change to 1, 1. BB we change to 1, 1. Okay? To standardize all, we can have here as R1, and this is equal to 0. So this is the standard form of compatibility equation that can be applied to all type of structure. Okay, this is the compatibility equation. This is the standard form. This is the standard form. Anyway, we can also use a symbol delta B naught plus FBB, doesn't matter. We can use, instead of using number, we can also use delta B naught, delta C naught, delta D, doesn't matter. Tak salah pun. Okay. Cuma biasanya bila kita nak analyze, for example, bila MA is the redundant, kita nak tahu, kita tak nak lost the track. Okay, so we can have the compatibility equation written as this. So if, for example, if MA is the redundant, okay, the compatibility equation is delta 1 naught plus F11. Use here the redundant. MA is equal to 0. Okay, so that we know now, by using the redundant name here, we should know that we cannot use delta here because it is moment. Okay, so we change this to theta. Okay, remember the partner P and delta, M and theta. This is the partner. Okay, so if the moment is redundant, the displacement is theta. So that is why I will choose this one instead of using the standard form R1. So that we know that if it is moment, we should write the rotation, because moment, the pair of the moment and theta. Okay, P and delta. So if moment is the redundant, it is theta 1 naught plus F11 tak berubah, still remain the same. So F, kalau depan ni theta, F pun theta juga. F pun rotation juga. Dia automatically ubah ikut yang depan. Okay, tapi still kita sebut dia F, even though now it is a rotation. Okay, so if MA is the redundant, the compatibility equation is written as theta 1 naught plus F11 times MA equals to 0. So, if another one, if BY is the redundant, if BY is the redundant, it is delta 1 naught plus F11. Okay, change to BY here. BY is redundant, so we put the BY in the equation 0. So we have two options, whether we want to have moment as the redundant. So if moment as the redundant, it is like this, theta 1 naught plus F11 times MA. And if we want to have BY is the redundant, so the compatibility equation is theta 1 naught plus F11 times BY equals to 0. Okay, so this is the principle of superposition. The compatibility equation is come from the principle of superposition. So there are displacement, there are two displacement, and solving the displacement will give us the redundant. solving the compatibility equation will give us the redundant. Okay. That's all for today's session. Do you understand before we end the session today?
Yes.
Yes, Doctor.
You have the question? You have question?
No, madam.
Do you understand?
Yes,
Yes.
madam.
Okay. So please try to read the module and read the module. Try to actually you can try to do the derivation again. Okay, and that's the process. That's the process. Okay. So that's all for today's session. Hopefully you enjoy the class. Okay, do revision to fulfill your student learning time. Okay, so inshallah we will meet again next week because of the PKSP Bengkel. We will have this 2-hour session, but physical session we don't have next week. The 1 hour physical session we don't have next week. So for the 1 hour physical session, I will replace with video. One video example of analysis of beam to solve one beam problem. Okay, so that's for next week. So please watch the video. I will later on I will give you the link for the video, and of course next week we will focus on beam analysis. So 2-hour session. 2-hour session I will tell you next week whether sempat tak sempat, because the bengkel until Friday, Monday until Friday. If saya tak sempat buat kelas in the morning, maybe I will change this slot to night slot for the 2-hour session. So 1 hour video and 2 hours live session will be on Friday night. Okay?
Okay, Doctor.
Okay, thank you all. Thank you for participating, active participating. Thank you very much. Okay, insyaAllah ada soalan? Ada soalan?
Tak ada,
No, tak
Doctor.
ada.
And don't forget, you have to submit 2 things, yeah. 2 things. One is the the diagnostic test, 10 question, only 10 question diagnostic test, and also the formative assessment for this week, the video, 1-minute video, okay, about this flexibility method. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you,
Thank you,
Doctor.
Doctor.
Waalaikumsalam.
Thank you, Doctor.
Bye.